All right, this is 1.9, guys. It's going to be a fairly short lesson. It will be on your quiz, which is going to be on Monday. So I'll do the quiz review. I'll do a video tomorrow, and I'll post it. Make sure you guys have it, but your quiz is going to be on Monday. It's going towards second quarter. As far as first quarter is concerned, I'm done. Please don't email me asking me for points and can I just bump and all this stuff. Don't do that. All right. I'm going to go over this first example, number 1, and then I'm going to go over number 3, and then I'm going to go over number 5 for a second. So let's look at the first one. You guys already know how to do this algebraically. We've done this on your test. We had a test over it already. Algebraically, you're going to solve the inequality. You're going to find your critical points. Then you're going to do a little number line graph to tell what the interval notation is. Then you're actually going to graph it graphically, and I'll show you that in a second. But guys, when I have x squared, this is 3x squared. Does anybody remember what shape that graph makes? A quadratic? Nobody? A quadratic graph is a parabola. Looks like a U. All right. We're going to get into functions and stuff like that in the next chapter. So I'm not super concerned about the vertex and how low it goes, all that kind of stuff. I need you guys to know direction. This is a positive quadratic equation. How do I know, looking at 3x squared minus 14x, how do I know that that's positive? Correct. The a term is 3. There's no negative in front of it. If there was a negative, it would be an upside down parabola. It'd be like that. Okay? So if it's positive, it's going upwards. If a is positive, if a is negative, it's a downward parabola. Now, when I look at this to solve, what's the first thing I have to do? Algebraically, to find my critical points, what's the first thing I have to do? I got to subtract 5. I have to move the 5 to the other side. So this is going to become 3x squared minus 14x minus 5 equals 0. So if we're going to factor this, guys, what times what gives me a negative 15 when I multiply, but a negative 14 when I add. Negative 15 when I multiply, but a negative 14 when I add.
15.
Yep. So I'm going to have x minus 15, x plus 1. My a term is not 1, so I'm going to put the 3 underneath both of these. So I'm left with x minus 5 and 3x plus 1. You guys agree with me? Okay, so if I set both of those parentheses equal to 0, okay, so I'm going to say x minus 5 equals 0, and I have 3x plus 1 equals 0. So when I solve this, I get x equals 5, and over here I get x equals negative 1/3. So do your number line. You have negative 1/3 here, 0, and 5. All right, we're just like we've done before. We're going to use our number line to tell what our notation is, interval notation. So I have closed dots because this is a what kind of a sign? What does that say? Less than or greater than? Guys, 3x squared minus 14x is what than 5? Greater than. So this is an or. I have closed circles, or dots. I'm going to shade in opposite directions. So I have close here, it goes opposite way. Make sure that you're right. So go ahead and plug in 0. If I plug in 0 to the original inequality, should 0 work? Yes or no? No, it should not. So let's try that. If I plug 0 in here and here, is 0 greater than or equal to 5? No. So I am correct here. So algebraically, what is the domain? What is the interval notation? What are the x values that I can use? How would I write it according to what I graphed? What would I write? Negative infinity to negative 1/3. Bracket, good. Then what? A u, 5 to infinity. All right? That is algebraically the answer that I'm looking for. Now, graphically, this is super easy. You guys found the intercepts. Where does this parabola that I'm going to draw cross the x-axis? In 2 places. Where? What are my two x's that it crosses at? X equals what? 5 and? What are my two x-intercepts? Where and where? I have them circled where it says x equals. Negative 1/3 and 5. So I'm going to go right here to 5. 1, 2, 3, 4, 5. And negative 1/3. It's going to be between 0 and negative 1. All right? Now, what kind of a parabola is this? A positive one or a negative one? It's what? No, what kind of a parabola is this? Positive or negative? Positive. So all I'm looking for you guys to do is to draw your U through the x-intercepts. I don't care how far down you go. Just make sure you go below the x-axis. I don't care how high up you make your arrows. But graphically, this is what I'm looking for. This question says greater than or equal to. When I get here, we're going to have it become 0. Where on the x-axis, all right, we're talking about our x values that we're allowed to use are from negative infinity over here, all the way here to negative 1/3. Then I can use again from 5 to infinity. So when you graph this graphically and they're asking for, or they're telling you that it's greater, you want everything above the x-axis. So you would color in, or you would tell me that this part of my graph is what I can use. You can either circle it, whatever you want to do. But when it says greater than, you want all of the parts of your graph that is above the x-axis. Because if you look right here, these values don't work. In between, they don't work. That's why we don't color in. But you've already told me that algebraically in the green, what x's I can use. But when the question is a greater than or equal to, the part of your parabola that I want to see is what is above the x-axis. If you want, you can erase this part. You can go like this and tell me that's the only thing you need. Or you can keep it like I had it here, and just do something to let me know, hey, this is the part that I want you to look at. Either color it, circle it, something, so I know that you guys understand. If the inequality starts off with greater than or equal to, they want everything above the x-axis. So if we go down here to this one, yep.
On like the answer, like it's like a parentheses and what do you get the parentheses? I thought it was just like always like
On in infinity,
yeah.
always parenthesis on infinity. Always. Okay, if I go down here, guys, this is already set equal to 0. So let's find our critical points. I have to factor this. What times what gives me a negative 5 when I add, but a positive 6 when I multiply? Negative 3, negative 2. So x minus 3, x minus 2. So my two critical points are at x equals 2 and x equals 3. That's also going to be the x-intercepts on my graph when I make my parabola. So I have 0, 2, 3. At the beginning, what was our inequality? Less than. What do we do with and? In the middle. So I have closed dots because it's or equal to. So between 2 and 3. So how would you guys tell me everything between 2 and 3? How would I write that in interval notation? We just had a test on this. Bracket, 2, comma, 3. Okay. Algebraically, you just told me what my domain is, what my values are that I can use. Now, graphically, you're going to plot your intercepts where it crosses the x-axis. This is going to be a skinny one at 2 and 3. Is it a positive parabola or a negative one? Positive. So just make your U like this. Again, don't care how far down you go, anything like that. But this question started off, and they want all the stuff that's less than or equal to. So if I'm going to color, what part of the graph do I want? If greater than was above the x-axis, then less than is going to be where you think? Below. So this is the part of the graph that I'm concerned about, that I care about. So somehow you guys need to let me know that when I ask you to graphically answer this. You either need to circle it, do a different color, whatever you need to do. Another thing, the way that you can think of, if you have an OR graph, the top one was OR, where did we color if it was an OR graph?
On top.
On top. If it's an AND, where do we color?
On bottom.
On the bottom. Super easy. Last thing I want to go over is this. Can you, do you see how I highlighted it? This is an OR on top. This is the part of the graph that I care about. And this is an AND. This is the part of the graph I care about. So somehow you have to let me know that that's where you want me to look. Now, if I look at this last one, and then I'm done. Can I factor this?
Yeah.
What times what gives me a positive 6 when I multiply, but a negative 4 when I add?
Nothing.
Nothing. So I'd have to use the quadratic formula. So real quick, you guys don't have to do this, just watch. I have negative 4 plus or minus negative 4 squared minus 4 times 1 times 6 all over 2 times 1. So this becomes 4 plus or minus 16 minus 24 over 2. What's 16 minus 24? 16 minus 24. Negative what? Negative 8 over 2. All right, so if I simplify, again, you don't have to do this. I'm just trying to show you something. 4 plus or minus. If I break down negative 8, it becomes 2I root 2 over 2. I can simplify here. That cancels out. This becomes a 2. So I have 2 plus or minus I root 2. If you get an equation like this and it says to graph it, does anyone know where to put that on a graph? Can I graph this on a normal coordinate plane? Why not? Because it's imaginary. In this case, you would say there's no x-intercepts. So if you had something like this, and I said to you, graphically, what would your u would be above the x-axis, therefore your inequality would be no solution. So I just wanted to bring that to your attention if you guys see that.